Welcome to the Digital Testing Suite. I'm your master coach, and today we are executing a complete system override on one of the most notoriously difficult areas of the Cambridge Mathematics 9709 syllabus, Section 3.8, Formulating Differential Equations from Rates of Change. Now, if you've been tracking your own performance grids, you already know this is where the vast majority of candidates hemorrhage marks. But by the end of this session, we are going to push your personal mark yield meter from those lower, inconsistent bands straight into a clean, undeniable A or A-star territory. We aren't just looking at math today, we are decoding the exact examiner playbook. We are going to look at the real-time tracking grids, apply text highlighter overlays to actual student responses, and build a structural framework that is completely bulletproof under extreme exam pressure. Here is our tactical roadmap for today's masterclass. 1. Decoding rate of change. 2. The procedural framework. 3. Top 3 examiner traps. 4. Mastering critical analysis. And finally, 5. The ultimate exam strategy. Let's get straight into it. Section 1. Decoding rate of change. Right out of the gate, we have to understand what the Cambridge Assessment Objectives, or AOs, actually demand from you. The official syllabus explicitly states that top-performing students exhibit a, quote, connected conceptual understanding transferable to unfamiliar contexts. What does that actually mean for you when the clock is ticking? It means rote memorization of formulas is practically useless here. Examiners intentionally design these questions to be totally novel scenarios. You have to adapt your mathematical toolkit to a word problem you have literally never seen before. We need to decode the command words. There is a massive difference between state, formulate, analyze, and evaluate. If a question says formulate, it's an AO1 or AO2 task. You extract the math. But if it asks you to evaluate the validity of the model and you just give them a raw equation, you've completely misread the command word. That triggers an immediate marking penalty on the examiner's grid. They cannot give you high-level analysis marks for foundational definitions. To really understand this, I want you to picture two scholars in a shared study suite. Let's call them Alex and Sam. Alex represents the average student mindset. Alex loves to overload paragraphs with raw factual definitions and generic mathematical statements. Alex focuses on superficial breadth. On the other hand, we have Sam. Sam is a fast writer who constructs highly persuasive arguments and prioritizes analytical depth. But Sam sometimes misses the explicit restrictions set by the command words. The assessment framework always rewards systematic, evidence-based reasoning. You have to combine Alex's factual accuracy with Sam's analytical depth while avoiding their specific weaknesses. If you rely on a scattergun approach, throwing every differential equation you know at the page, the examiner's mark yield meter flatlines. You have to prove exactly why your specific equation governs the physical system described in the prompt. Section 2. The procedural framework. Now we are getting into the operational attack plan. This standardized sequence is your non-negotiable checklist for every single rate of change question. Step 1. Identify key variables and constants. Step 2. Apply relevant principles. Step 3. Execute the analysis with clear working. Step 4. Verify your results. And Step 5. Present in the appropriate format. Now, let me introduce you to the marks per minute formula. You must allocate your time based on the exact tariff of the question. If this formulation is worth 3 marks, you have roughly 3 to 4 minutes. You scan the text, hit Step 1 by identifying if the change is proportional or inversely proportional, and immediately execute Step 2. If you skip verifying your results against the initial conditions, say at time t equals 0, you are actively throwing away the final presentation marks. This sequence creates a safety net. Even if you make a tiny arithmetic error later on, following this framework ensures you capture every single process mark available on the examiner's rubric. Let's go back to our two scholars, Alex and Sam, sitting in their study suite staring at a dense paragraph about a leaking cone where the volume decreases proportionally to its current volume. Alex immediately says, okay, the data says proportional, so I'm just going to write down dV over dt equals k. But Sam stops him and says, wait, look at the complex relationship. It says decreases. If we just write a positive k, our evidence-based conclusion is going to show the cone gaining volume out of nowhere. We need a negative sign. It has to be negative k times v. Then Alex argues, well, let's just use x and y. It's faster for the analysis step. And Sam fires back, no, the examiner explicitly gave us v for volume and t for time. If we don't present with proper headings and correct terminology, we violate the format restrictions. This right here is exactly the debate you need to be having in your own head. Translating a word problem requires absolute precision in extracting data and ensuring clear annotations. The variables you choose must perfectly mirror the reality of the text. Section 3, Top 3 Examiner Traps. It's time for an interactive visual workshop. I want you to imagine a 60-second countdown timer running right now. We are going to spot the examiner traps directly from the principal examiner reports. Trap 1. Using the wrong approach for the context. I see students trying to apply a linear model when the text explicitly implies an exponential decay. The fix? You must select the specific analytical framework the text demands based on the keyword scan. Trap 2. Forgetting to check format and presentation. This is what Sam was warning Alex about. Using generic X and Y instead of the specific variables given in the prompt. But here is the most fatal flaw. Trap 3. Providing generic, non-specific answers. Look at the fix on the board. Link every single point to the given scenario. I'm putting a digital highlighter over this right now because I cannot stress this enough. Contextual misfires are the #1 reason candidates drop out of the top-tier marking bands. Let's do a trap spotting exercise. Imagine a flawed medium-tier sample student paragraph on screen. It reads, the population grows, so the equation is dp/dt equals kp, which means it grows forever. Where does the logic drop? Right at the end. They provided a generic math statement but completely ignored the physical scenario. A biological population cannot grow to infinity. There are space and resource constraints. If your differential equation doesn't explicitly account for the specific physical limitations of the scenario, like a temperature that cannot drop below the ambient room temperature, the examiner cannot award you top marks. Context is absolutely king here. Section 4. Mastering critical analysis. Strategy check. Before we unlock this top-band paragraph structure to help you crush your upcoming sessions, make sure your revision feed is perfectly optimized. Take a second right now to subscribe to Ace the Exams at Ace the Exams and enable all notifications so you never miss our weekly Cambridge exam breakdowns, no matter if you are sitting for IGCSE, O-levels, or AS and A-levels. Okay, back to the masterclass. How do you actually prove analytical depth to an examiner? You've formulated the equation, you've plugged in the numbers, but how do you demonstrate the higher-order assessment objectives? You need a structural matrix. In subjects like English, they use the Peel framework: point, evidence, explanation, link. We use a mathematical variation of that right here to anchor our arguments. Let's look at how Alex and Sam upgrade their structural matrix using these 4 pillars of evidence quality. They've hit an unexpected roadblock mid-paragraph. Their equation is perfect, but the command word is evaluate the validity of the model for large values of t. Alex just writes, the model works. That's a foundational, low-band point. Sam steps in to use our framework. First, they identify limitations in the data. Sam writes, the model assumes the rate of cooling remains strictly proportional to the temperature difference. Then they note the assumptions. However, this assumes the ambient room temperature remains perfectly constant over a large value of T, which is physically unlikely. Finally, they assess the effect on the conclusions. Therefore, for very large values of T, this differential equation may overestimate the rate of cooling. Do you see what just happened? They rewrote the text line by line, out loud, engineering a flawless, top-tier response block. They aren't just doing the math, they are ruthlessly evaluating the assumptions of their own mathematical model. This is the exact leap you have to make, moving from the descriptive level to the evaluative level. Let's do another 60-second visual data scan challenge. If you look at a complex case study, a descriptive answer just identifies basic similarities. The graph goes up, so the derivative is positive. That's descriptive. But to hit the evaluative level, you must use comparative connectives, support it with rigorous mathematical evidence, and conclude relative importance. You need to say, while the initial rate of change is strongly positive due to the large value of k, as time t approaches infinity, the rate of change decreases, indicating a limiting factor in the physical environment. You are proving depth by critically evaluating the quality of your evidence and justifying your mathematical recommendations. Section 5. The ultimate exam strategy. We've covered the traps, the methodology, and the debates. Let's distill this entire session into 3 universal Cambridge operational rules for your tactical attack plan. Rule number 1, the 3-step question scan. This is where you deconstruct the question, decode the command words, and extract the relevant data before you even touch your calculator. Rule number 2, the marks per minute formula. You select your analytical framework and allocate your time strictly based on the mark yield of that specific question. Do not spend 10 minutes on a 2-mark formulation. And rule number 3, the post-writing compliance audit. This is where you execute with clear notation and verify that you have presented your final answer with the exact terminology the examiner requested. Memorize this chronological strategy. Executing this specific sequence ensures your working is logically structured, totally examiner compliant, and beautifully presented. Alex and Sam cracked the code by combining raw, factual accuracy with deep, structured evaluation. and now you have the exact same blueprint. Before you head off to run your post-writing compliance audit on your past papers, make sure you've joined our elite study suite. Subscribe to Ace the Exams at Ace the Exams and click that notification bell. We are dropping these high-energy grade masterclasses every single week, and you need this tactical intelligence in your feed. Now, I want to hear directly from you. Drop a comment below sharing exactly which Cambridge subject and level you are preparing to conquer next. Are you tackling IGCSE, O-level, AS, or A-level? What specific paper is your biggest roadblock right now? Let me know down in the comments. Remember, true mastery doesn't come from memorizing textbooks. It comes from systematic, evidence-based practice and a relentless focus on the examiner's exact requirements. Master the structure, and you master the exam. I will see you in the next explainer.